Dear friends, let us learn the basics required to study fluid mechanics. So, myself, Dr. R. Sumitra, giving you the basics of fluid mechanics. A fluid is a substance which is capable of flowing, and they are divided into two categories. One is incompressible fluids, the other one is compressible fluids. Incompressible fluids are called liquids and compressible fluids are called gases. And they have the five basic physical properties. They are density, okay, they are volume, temperature, pressure, and viscosity. The subject mechanics deals with the study of motion of physical objects and forces that cause such motion. Knowledge of mechanics is needed for all subjects of applied mathematics, physics, chemistry, biology, and it has wide applications to the problems of real world. The study of mechanics, if the physical object is a solid, then the subject is called solid mechanics. If the physical object is a fluid, then it is called fluid mechanics. As simple as that. Now let us learn some basic concepts. First, let us learn what is viscosity. Viscosity is the property of the real fluid because of which there will be some resistance to the shearing or the sliding movement of one particle past or near another particle. Viscosity is also known as internal friction of the fluid. All known fluids have their property in varying degrees. Viscosity of glycerin and oil is large when you compare with that of water and gases. Let us see what is a perfect fluid. A fluid is said to be perfect or ideal if it doesn't exert any shearing stress, no shearing stress at all. Ideal fluid is also called as perfect fluid, frictionless fluid, inviscous fluid, non-viscous or inviscid fluids. Let us come to forces. There are two types of forces acting on a fluid element: body force and surface force. Body force is proportional to the mass of the body on which it acts. The surface force acts on the boundary of the body, so it is proportional to the surface area. So remember, body force is proportional to mass of the body and surface force is proportional to the surface area of the body. The normal force per unit area is called normal stress and it is nothing but pressure. It's nothing but pressure. What is the tangential force? The tangential force per unit area is called shearing stress, or in other words, it is also called tangential stress. The difference between perfect and real fluid. In the case of perfect fluid, only normal stress exists. The only stress that exists is normal stress and no tangential stress. No tangential stress. In the case of real fluid, both normal and tangential stresses exist. Let us see what is density. Density is nothing but mass by volume, the ratio of mass and to that of volume. Mass is nothing but density into volume. In other words, what is specific weight? Specific weight is nothing but weight of the fluid divided by volume of the fluid. Weight of the fluid is nothing but mg by volume is, let us take it as capital V. And we know that what is capital V? Capital V is nothing but mass by density. So substitute. So we are going to get the specific weight is nothing but rho into g. Rho is density and g is acceleration due to gravity. To study fluid mechanics, we should know what is called continuum hypothesis. Let us see what is continuum hypothesis. Every physical object or matter is made up of molecules, atoms, and even smaller particles. These particles are not continuously distributed over the physical object. The microscopic observation reveals the presence of gaps between the particles. Thus, we have two types of studies, namely, the study that takes into account of these gaps in the physical object, and this study is called microscopic study. The study that ignores the gaps and treats the physical object as a continuous, the word continuous is very, very important, continuous distribution of matter, and the study is called macroscopic study. The macroscopic viewpoint adopted in the study of mechanical behavior of physical object is called continuum hypothesis. And to learn fluid mechanics, we adopt this viewpoint, the macroscopic viewpoint. So we assume the physical object is continuously distributed. It is a continuum. So full fluid mechanics is based on continuum hypothesis. Now, as we all know, division of physical matter is something like this. Physical matter can be divided into solid, liquid, gases, and plasma. Liquids and gases together are called fluids. And mechanics can be divided into two branches. One is statics, the other one is dynamics. Statics, we study the physical objects at rest, right? Whereas the branch of mechanics that deals with the objects in motion is called dynamics. Let us see what is line integral of a vector function. We need all these things to study fluid mechanics. What is a line integral? An integral which is evaluated along a curve is called a line integral. And that is equal to, we know that it will have two limits, upper limit and the lower limit, f dot dr by dt, where r is the position vector and f is the vector function, c is the curve, a and b are its endpoints. So this is the definition of the line integral, where t is a parameter. Let us see what is Gauss divergence theorem. Let S be the closed boundary of a region of volume V, then for a continuously differentiable vector field F defined on V and on S, we have the surface integral, double integral, right? F dot n ds is equal to volume integral divergence V dV, where n is the outward unit normal at any point on the surface ds. This is not s here, this has to be ds. This has to be ds. So we can convert surface integral to volume integral or volume integral to surface integral and vice versa, right? Okay. Now similarly, we have Stokes theorem. What is Stokes theorem? The line integral of the tangential component of a vector f around simple closed curve C is equal to the surface integral of the normal component of curl f over any surface S having C as its boundary. So we have the line integral. We have the line integral here. We have the line integral, right? That is equal to surface integral. So line integral f dot dr. Line integral f dot dr is nothing but surface integral curl f dot n ds, where n is the outward unit normal at the small surface ds. So you can convert line integral to surface integral or surface integral to line integral. Now, to study fluid mechanics, we need something called what is gradient of any scalar field. Let us see what is gradient represents actually. The concept of gradient describes the rate of change of a scalar field. If phi represents a surface phi xyz equal to c, then gradient of that phi is nothing but del phi, that is equal to dou phi by dou xi, dou phi by dou yj plus dou phi by dou z k. If r is the position vector at any point P on the surface, what is dr? Dr is just a differentiation, right? And this dr lies on the tangent plane to the surface at the point P. What is the dot product of gradient phi and dr? Dot product, if you take the dot product of this gradient phi and dr, that is nothing but dou phi by dou x dx plus dou phi by dou y dy plus dou phi by dou z dz is nothing but total differential d phi, is nothing but d phi. And since phi is constant, so d phi is 0. That means what? What is LHS? LHS is this. So del gradient phi or del phi dot dr equal to 0. That means what? The dot product, when the dot product of two vectors is equal to 0, we know that first vector is perpendicular to the other vector, right? The first vector here is gradient phi. So gradient phi is perpendicular to dr. So, and where is dr? Dr is along the tangent plane, right? So, since the gradient phi is perpendicular to dr, so this gradient phi will be along the normal to the surface. So gradient phi denotes normal to the surface. And this gradient describes the rate of change of that phi, the scalar field phi. That is about gradient of phi. Let us see what is rate of change of a vector field. Rate of change of a vector field, there are two fundamental measures, right? One is divergence, the other one is curl. Let us see what is divergence of a vector field. Divergence of a vector field denotes the extent to which that vector field can explode or diverge from that point in all the directions. That's the meaning of divergence of a vector field, and denoted by del dot f. Del dot f. And del dot f is a scalar field. And that is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, where f1, f2, f3 are components of the vector field f. Right? Then if that del dot f is equal to 0, then f is called solenoidal. That means no vector field diverges. It will not explode. That's the meaning of del dot f equal to 0. That's the meaning of f is solenoidal. The examples are gravitational field and the electrical field. Let us see what is curl of a vector field. Curl of a vector field denotes how the field swells in the vicinity of that point. Curl F is associated with the rotation or spin of that vector field F, denoted by curl F or del cross F. Del cross F is nothing but in the determinant form ijk, first row, second row, we know dou by dou x, dou by dou y, dou by dou z, and the third row is f1, f2, f3, the components of f. That's nothing but del cross F. If del cross F equal to 0, then F is called irrotational. F is called irrotational. A vector field F is said to be conservative if there exists a scalar field phi such that F is gradient of phi, where this phi is called the scalar potential of the vector field F, such that we get a curl of this gradient phi equal to 0. That is curl F equal to 0. That is F is conservative. So a vector field F is conservative if F is irrotational. If F is irrotational. Let us see in physically how they look like. See, curl represents the spin or the rotation, and the divergence is the extent of that vector field to diverge, to expand or to diverge. Okay, so these are the basics required to study fluid mechanics. So we shall stop today, and in the next class let us learn some basics, some more basics of fluid mechanics. Thank you.